take a look at a fairly basic example of anti-differentiating the chain rule, and this is something that we do through the process of u substitution. What we are ultimately looking for here is some piece of our function that is a derivative of some other piece of the function. Typically the derivative part is going to be kind of added on, and we got that when we went through the chain rule. And then there's another piece of the function that's going to kind of have an inner and an outer part, and typically our u is going to be that inner part, and the derivative of u will be this extra thing that we have somewhere else in the function. So for example, if we look at the problem we have here, the antiderivative of 3x squared minus 4 to the third power times 6x, if we look at what's inside that power function, 3x squared minus 4, and consider its derivative, well, that's the 6x that we see out here. So that's the pattern that we're going to be looking for. We're going to be looking for the pattern that is the end result of the chain rule. If we can identify that pattern, then we should be able to take the chain rule and move it backwards. So the general process to do this is to assign the first thing that we found, 3x squared minus 4, to a value u. And then we're going to take the derivative of u, which is 6x. And technically that's the derivative of u with respect to x. But what we're going to do is we're going to multiply both sides of this by dx. And in so doing, we're going to move that dx over here. So now I can replace the 3x squared minus 4 with the u, and I can also replace the 6x dx with the du. The substitutions are perfect, nothing's left over, nothing is overly substituted, I guess we could say. And we can completely convert this integral over to something in terms of u's. So we'll say that this is the same thing as the antiderivative of u to the third du. Again, 3x squared minus 4 is getting replaced with u, 6x dx is getting replaced with the du. Now, when we see the first one, it doesn't look like something that we know how to take the antiderivative of, but when we put it into this u format, it looks a lot more familiar. So anti-differentiating, we're going to get 1/4 u to the fourth plus c. If we undo our substitution, we're going to get 1/4 times 3x squared minus 4, since that was our u, to the fourth power plus c. And there's the result we were looking for. Apply the chain rule to this, take the derivative, and you should end up with 3x squared minus 4 to the third times 6x. So once again, as we've been seeing all along, the best check to an anti-differentiation problem is to differentiate your answer and make sure you end up with the original integral.